Hello and welcome to this video. Now this is a continuation video. In this video I am discussing how to balance redox equation after identifying the element which is getting oxidized or getting reduced. The redox equation is splitted into two different half cells, that is reduction half cell and oxidation half cell. In reduction half cell we will write all the elements associated with the compound which is getting reduced, and in the oxidation half cell we will write all the elements associated with the compound which is being oxidized. For example, in oxalic acid carbon is getting oxidized, so the compounds which are containing carbon on the product side would be considered in the oxidation half cell. Similarly, in potassium permanganate, manganese is getting reduced. Compounds containing potassium, manganese would be considered in the reduction half cell. Now, if you notice, potassium is being converted into potassium sulfate in products. So we have, because sulfate is present, so we have to consider sulfuric acid as well in the reduction half cell. Potassium in potassium permanganate and sulfuric acid are considered as spectator ion and spectator molecule respectively in this redox equation. Now both the half cells would be balanced separately. The first step in balancing is the element which is getting oxidized or reduced is to be balanced, and after balancing this element, the remaining spectator molecules or ions that are present would be balanced accordingly. Take a note of it that all the elements excluding hydrogen and oxygen present in the half cells should be balanced before moving on to the next step. Balancing the elements in the half cells is done using hit and trial method. It is, you just calculate the total number of elements of a same type that are present on the reactant side, and accordingly you balance them on the product side. For example, in oxalic acid there are two carbon atoms, so on product side we would be multiplying carbon dioxide by 2, thus carbon is being balanced. Similarly, in the reduction half cell, the product formed potassium sulfate, it is 2 potassiums are present, so we multiply potassium permanganate with 2, so accordingly manganese is to be multiplied by 2 on the product side, and to balance now sulfate ions we have to multiply sulfuric acid with 3, so the equation is balanced. Rewriting the above balanced equation again, we have now calculating the collective oxidation state of the element which is getting oxidized or reduced. Now the collective oxidation state means the oxidation state of the total number of elements that are present on the reactant side and total number of reactants that are getting oxidized or reduced are present on the product side. For example, in oxalic acid there are 2 carbon atoms. The oxidation state of a single carbon atom is plus 3, so it is to be multiplied by 2 because there are 2 carbon atoms, and it would be, to the total oxidation state would be plus 6. Likewise on the product side it would be plus 8, so the difference in oxidation state would be plus 2 between reactants and products. So oxidation state of carbon is changing by 2 because this is an oxidation reaction, so we will add electrons on the product side. Similarly, in case of potassium permanganate, there are 2 manganese ions, so total oxidation state of the manganese present in reactant side is plus 14, and the total number of oxidation state of manganese in the product would be plus 4, so difference is of 10 electrons, so 10 electrons are added on the reactant side. So I am again rewriting the above equation with electrons. After balancing electrons, we would use the medium which is present in the redox equation to balance hydrogen and oxygen. Now this equation is having sulfuric acid, so we would add acidic medium for balancing redox equation. In acidic medium, we can add H plus ions and water molecules as per our requirement on any side of the oxidation or reduction half cell to balance hydrogen and oxygen. It is important to understand that it is not like that hydrogen ions are only added to the reactant side and water molecules is added to the product side. It can be either way. It all depends upon the requirement of the reaction or requirement of the half cell. If requirement is that water molecule is to be added in the reactant side and H plus ions are to be added in the product side, then it is also possible. Similarly, vice versa of this is also possible. In some equations, there may be a case that you add H plus ions in reactant side and you also add H plus ions on the product side. Similarly, in some equations, there may be a case that you add water molecules on the reactant as well as on the product side to balance the half cell. So in acidic medium, you have to add H plus ions and H2O, and it is basically the requirement of the equation. You can add both of these or either one of these to balance your equation. Now after balancing both hydrogen and oxygen in the half cells, we have to add oxidation and reduction half cell. So rewriting the balanced oxidation half cell and balanced reduction half cell. After rewriting these equations, we have to equate the electrons of both the equations. So we multiply either one of these equations or both the equations by a number so that electrons get equated. Now in this case, there are 2 electrons in the oxidation half cell while there are 10 electrons in the reduction half cell. So we can only multiply the oxidation half cell with 5 to equate the electrons. So after multiplying the oxidation half cell with 5, the oxidation half cell equation turns to be, now adding both the equations, and we would be eliminating the common compounds or elements which are present in both the half cell in opposite sides. That is, if our hydrogen ions are present on the reactant side of one equation and hydrogen ions are present in product side of the another equation, then the common can be eliminated. Similarly for water molecules, electrons and all other ions or molecules. In this equation, hydrogen ions and electrons get completely eliminated while water molecules from the oxidation half cell get completely eliminated, while water molecules are present in the product side on the reduction half cell. So after eliminating the elements or compounds, we have to add the half cell. So adding the half cells, we get the balanced redox chemical equation. The balanced equation is 2 moles of KMnO4, 5 moles of oxalic acid, 3 moles of sulfuric acid on reaction gives potassium sulfate, 10 moles of carbon dioxide, 2 moles of manganese sulfate and 8 moles of water. So this is method of balancing redox equation. Register on myetutors.com to practice unlimited MCQ test for all engineering and medical entrance examination, namely IIT, JEE Mains, BITSAT, Manipal, All India PMT, AIMS, etc. Thanks for watching this video.